EEE-CONTENTS.
Dear students, now let's conduct the experiment called half-wave rectifier in Multisim 14.2 platform. Okay. Now first let's understand what do you mean by this half-wave rectifier. Rectifier will going to give rectifier is a circuit which will going to convert from AC to DC. But in the half-wave rectifier, we're going to get pulsated DC. A complete full cycle will not going to rectify here. Only we'll going to get only half cycle we're going to rectify. Okay. What will happen for another half cycle? Let's check it out and calculate with half-wave rectifier with filter and without filter. That is nothing but we are going to use capacitor filter. And here we are going to find out the determination of ripple factor, regulation, and efficiency of the half-wave rectifier. Okay. Now let's understand the circuit diagram. Okay, these are all the components required. That is nothing but AC power, center tapped rectifier, diode, resistor, capacitor, and oscilloscope. Okay, this is nothing but a AC power or AC voltage, and then this is nothing but a center tapped rectifier. Sorry, center tapped transformer or transformer, normal transformer. Okay, sorry. Okay, please change this one as center tapped transformer or transformer. Okay, here we are going to take down this transformer and then diode, that is nothing but 1N401, and then here we are going to use one resistor across diode and transformer, and then for input here we are going to use two channel oscilloscope. A channel I'm going to connect it to the input, B channel I'm going to connect it to the output. Okay, let's simulate in the Multisim platform. Before that, I'm going to show you the waveform. This is the red color waveform is nothing but input waveform, and the blue color waveform is nothing but a output waveform. Okay, here what will going to happen during positive off cycle diode will going to conduct. Why? Because positive is connected to positive, negative is connected to negative. So that's why our diode will going to conduct during positive off cycle, positive off cycle. But during negative off cycle, diode will going to act as a reverse bias. So we're going to give zero voltage. So that's why our half-wave rectifier only operates in during positive off cycle only. So we will not going to get perfect DC. So that is the main agenda. And then here in the calculation, we need to find out the value of VDC. We need to find out the value of VDC. What is the output voltage, DC voltage? And then we need to find out the VM maximum voltage with type of this formula. Now, those value go to VDC, we can find out all the values. Okay. VDC VM is equal to VDC into pi. IM is equal to VM. What we calculate before, VM divided by RL. What is the value of RL? Here I took 1 kilo ohm. Here substitute here, we are going to get IM. And then IDC. IDC is equal to IM, what we calculated previous. IM divided by pi. VAC is equal to VM divided by 2. And then IAC is equal to VAC divided by RL. Okay. Ripple factor, what is the formula? Square root of IAC divided by IDC whole square minus 1. Efficiency is nothing but theta is equal to IDC divided by IAC whole square into 100. Regulation is nothing but VDC no load minus VDC full load divided by VDC full load. This is how we need to calculate the parameters, ripple factors, efficiency, and voltage regulation. Okay. First, let's see conduct half-wave rectifier without filter. Okay, I'm going to conduct without filter. Let's see. Put it as a reference circuit. I'm going to take down first AC supply. Before that, how to open Multisim, I'm going to show you. This is nothing but a icon of our Multisim. This is nothing but an icon of our Multisim 14.2. Whenever you will go to double click on that icon, you'll go to get this kind of page. Here, I'm going to save first. Go to file and save as and save the circuit simulation part. Simulation you need to save first. Where you will go to save whatever it may. You can choose your own path and save it. Okay. I'm going to save in the F drive 02. Already make one circuit that is nothing but 01. Here another one, repeat it one 02. Okay, here the name will going to reflect here and here also. Here also. Okay, no need to worry. Otherwise, everything is fine. Only file save as, that's it. Okay. Okay, now I'm going to select the or drag the components from uh, library. How to drag the components from the library? There is a two methods. You can go to the place and components. This is the one method. Another method is, this is a better method, place component. Okay, this is the basic method, better method. By default, it is in master database. You kept it in master database. By default, it should be in group, all groups. Okay, all groups, all groups by default. Okay, it is very easy to extract the components. Okay, now by default, database should be in master database, group should be in all groups. Okay, otherwise you're going to get sources, only sources you're going to get. Basics, you will go to only basics you will going to get. Diodes, only diodes will going to get. But here, all the groups you can type here with all groups it going to, you can type here any. For example, you need to one transformer. Okay, transformer, you're going to get one transformer. Okay, transformer rated transformer, you're going to get one resistor. You will need, you want, you will going to get one resistor, whatever it may be. You can choose anything you can type, you're going to get the component. Okay, that's the method. Otherwise, for example, you kept very basic diode, you will only get, you're going to get only diodes, only resistors. So that's why for easy purpose I'm going to kept it in all groups. Okay, now first I need one AC power now. Okay, what is there here? AC power. Okay, I'm going to choose one AC power. AC AC power. Okay, AC power. Source, just type source. Just type AC. Okay, AC power you're going to get. AC power. Just okay. Place it here. And then what you will require, transformer. Na? So one primary, one secondary, one P, one S. You're going to get this kind of transformer, two winding transformer. And then what you require, diode, 1N400. Just type 1 and just 400. You're going to get n number of diodes. Okay, you can choose any one. Okay, next one, what you require, resistor, RES, resistor, rated resistor. What do you mean by rated resistor? You can vary the value, 1K, 2K, you can change. Another one, what required, ground. Ground is very, very important. Ground. Okay, ground. Okay, ground. Yes, what we required other than this, I required one oscilloscope, means CRO. So here you need to take down where it is, here, right corner, multimeter, function generator, wattmeter. I required oscilloscope, two channel oscilloscope. There is a four channel oscilloscope also, but I required only two channels. So just concentrate on two channel. Okay, Control C, Control V, copy paste. Okay, okay. Before that, I'm going to do the connection now. From positive to transformer, positive terminal. From negative to negative terminal. From positive out secondary of the transformer to diode positive, and then transformer negative to diode negative. Okay, this is the one. Okay, next ground. Here in the output side, I'm going to connect one resistor. Control R to rotate. Control R you need to use. Control R, and then this one to here. For simplification or need purpose, I'm going to delete, escape. Circuit should be need, and then ground. Okay, I hope clear. A channel, A channel. Here, minus minus you need to short and give ground. Control C, Control V. And then positive to output. Sorry, input. A channel you need to connect it to the input. What is the input? Positive terminal of the transformer. Okay, input. Output, we need to connect across the output you need to connect across the register and we connect immediately. I will try to connect immediately. Anyhow, this will go to sharp. Don't worry about these shorts and all. Okay, that will not going to affect your circuit. So directly make the circuit, rig up the circuit. Okay, the circuit is ready. Now you need to change the values. Here 120 VRMS is good. So instead of 60 hertz, 50 hertz you need to set. And then transformer is also fine. 1:10:1. Step down transformer I am going to use. And then yeah, everything is fine. I'm going to run the circuit. You need to press F5 or just click on this icon, green icon. Okay, you're going to get this kind of waveform. This kind of waveform. Okay, waveform is not perfect. Waveform is not perfect. Okay, now I make small changes here. I gave separate ground for negative and here negative channels. Okay, here I am going to connect. I already connected output channel B to the across register. Let's check the output. Okay, output will going to come. So I'm not able to find out the output properly. So that's why I'm going to change the color of this wire, output wire, red to blue. Okay, okay. Now all of you observe the output. You can observe the output. I'm going to mute the input. Obviously, you can find out the output exactly. What is the value of this output? Let's check it out. How to check the value? Just manually you can check. What is the boxes here? You're going to cover 1.6 into 10. Channel B you need to check. Channel B 10 volts per division. Here one box is equal to one box is equal to one box 1.5 box. One box is equal to 10 volts. Here it's cover 1.5 means 15 volts. Output is 15 volts manually. Otherwise, you need to check automatically. Place here, you will going to get exact value 16.2. That is the value of output voltage 16.2. 16.2. Okay. Yes, I'm going to on input also. Okay. Otherwise, output you need to bring down. You can observe both input and output. Okay, this is how you need to check the input and output value without filter. Okay, students, now let's calculate the values. You need to take the value 16.2 and substitute here. All of you check, see the calculation part. Substitute here. Only one value, 16.2. VDC is equal to 16.2 with load. Okay, VDC is equal to 16.2 and substitute here. VM is equal to VDC 16.2 divided by into pi. We're going to get VM. IM is equal to VM. Already find out VM value. So substitute here VM divided by RL. What is the value of RL? 1 kilo. Just substitute. Same, you're going to get IDC, VAC, IAC, ripple factor, efficiency, regulation factor. Here in the regulation part, you're going to you already taken VDC full load. Here VDC full load. For VDC no load, you need to remove this resistance. You need to remove this resistance and take down the reading and take down the reading and take down the reading. Now, what is the value of output? Remove the resistance and take down the value. So I need to complete the circuit. Okay, I need to complete the circuit. So, and then you need to make it as 0. Normal position. Okay, 0. What is the value of output? Just hold on, and then check the value of output. you will not going to get anything. So ripple factor, you will going to get no load voltage is 0 in the channel B. You will not going to get anything. 0, everything is 0. So no need to worry. So 0 you can take. So 0 substitute here. No load 0 minus full load 16.2 divided by 16.2. 16.0 minus 16.2 divided by 16.2, we're going to get minus 1 into 100, that is nothing but minus 100. That is not perfect. Okay, VDC no load. Check VDC no load. So we'll try in another manner. Okay. Okay. No need to worry about this regulation. No need to worry about this regulation part. Okay, let's be back into the circuit, normal circuit. Take down one resistor, RES. That is nothing but okay. Control R to rotate. Use Control R. Run. You're going to get normal waveform. Okay. Okay, normal position. Don't worry about regulation. Find out ripple factor and efficiency. Now I'm going to connect one capacitor. Now I'm going to connect one capacitor across the resistor like this. Like this. Okay. Across the resistor, I'm going to connect one capacitor. Okay, in order to get the pure DC capacitor, CAP rated, you need to select CAP rated, capacitor rated. Here also same, you need to rotate Control R, and then this is to this place, this one to this place. This is across output. Okay, properly you need to done. Properly you need to make the circuit. So output to here you can connect, or here also you can connect. Run, check the output. Okay, you're going to get some output now. Some simulation error is there, so you need to connect ground. Okay, now let's check the output. Okay, I'm going to get the output, so I will going to change the color of the output, red to blue. Okay, run. Okay, you're going to get the output. Okay, in order to get proper, so proper, but here the capacitor value is very low, 1 microfarad. You need to in order to get better DC, you need to change the value from 1 microfarad to 8 microfarad. You're going to get some better DC. Okay, this is nothing but a pulsated DC output. Okay, yeah. Now you need to take the output voltage value, just put it in the peak and take down the value. That is nothing but a 13.4 T2 minus T1 R. You can put it here 12.037. You can take down, or directly you can take Directly we can put it in the 0 and take what is the value it will going to cover from here to here. What is the what boxes it is going to cover approximately 1.2 into 10. That is nothing but 12 ports it will going to give. Otherwise, directly put in the peak and get the value. That is nothing but T2 value. T2 value is nothing but 16.2. Directly you can take 16.2, or you will going to get manually or practical, both are same. 16.2 you will going to get. Detail again order you will going to get. You will going to get approximately 1.8 is nothing but 10. 1.8 1.8 into 10, that is nothing but 18 to 16, but maybe 1.6, maybe 1.6, that is nothing but 16. Okay, if you're going to cover from here to here, I'm going to show exact value 1.1, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6. Okay, 1.6 into 10, number of division, that is nothing but 10. 1.6 into 10, that is nothing but 16. Or directly you can take here, put it in the peak value and take down the 16.109, 190. What a value, and VDC full load value. VDC full load value we need to put here in the formula. VDC full load value here. VDC full load. You're going to get this kind of waveform. This is the circuit. This is the waveform. And here you need to do the calculation, same calculation. Directly you can take VDC full load value, that is nothing but 16.190, and do the calculation. You're going to get triple factor efficiency. Don't worry about regulation. Okay, this is how we need to conduct the half-wave rectifier circuit in the Multisim 14.2. Okay, thank you so much.